Oops. I mentioned that this is going to be the solution to problem 123. Not true. It's a solution to problem 125. Hello, hello, hello. Today is December 10, 2021. It's 9 o'clock in the morning for me. Probably not for you. Solutions of problem number 123. The humidifiers in my bedroom. For those of you who have watched some of my lectures, they knew the answer immediately. There are at least 4 lectures, but maybe even more, where I discuss Rayleigh scattering, which is the reason why the sky is blue, and I discuss Mie scattering, which is the reason why the clouds are white. Not only do I discuss it, but I do some very famous demonstrations, which, as far as I know, I've been the only one who ever did them. And you can see those demonstrations in at least 4 of my videos. It doesn't matter which one you take, but I suggest you use my farewell lecture at MIT of May 16, 2011, and it is about 30 minutes into the lecture that I do this demo. I lit a few cigarettes and I show you the smoke of those cigarettes. The particles, the smoke particles from the cigarettes are smaller in size than about 1/10 of a micron. And that's when Rayleigh scattering is active. The cross-section that light is scattered, so you shine white light, let's say sunlight, on the smoke, the light that is scattered backwards is a strong function of the wavelengths. The probability is proportional to 1 over the wavelength to the power 4. If we assume roughly that the red light has a 1.5 times longer wavelength than blue light, then the ratio of that to the power 4 is 5. That means that blue light has a 5 times higher chance to be scattered than white light. That's the reason why the sky is blue, and it is the reason why the cigarette smoke is blue. And some of you may have seen that at the outlet of cars, when they just start going and they have a leak in their oil system, they started to burn oil, and then the smoke that comes out of the exhaust is also blue. So I showed that demo. Very dramatic. And then I tell you that if the particles are 0.5 micron or even larger, then every wavelength has the same probability to be scattered. That means if you shine white light on it, white light is scattered. That's why clouds are white. You may say, well, when I look up in the sky, I often see very dark, not white. Well, if you were flying over those clouds, when the sunlight comes down on it, they would be white. But if they are very, very, very thick, then of course the light cannot even go through anymore, and that's why you see them dark. What I do then in my demo, I inhale the smoke of the cigarette and hold the smoke for about 2 minutes in my lungs. There is a lot of water vapor in my lungs, and water starts to precipitate on these very, very small smoke particles. And they easily become larger than half a micron. If I then exhale the smoke, it's white. It's a very dramatic demo, because to hold the smoke in my lungs for 2 minutes is not easy. So clearly, what you see in my bedroom, produced by my humidifier, are just very small water drops. They are exactly like a cloud. They are much larger than half a micron. And so, that's why they are white. They are nowhere nearly small enough to be affected by Rayleigh scattering. So that was an easy problem. And the light that you then see coming through my window into the living room, into the bedroom, you also see sort of a beam of light. That is undoubtedly due to dust in the bedroom. There's always dust in the air. And that's why you see it's like a lane coming to you. Well, most of you have this right. Some of you say it's Tyndall effect. No, it's not. But I do encourage you to watch my famous cigarette demo. You can see it in lecture 4 of NHK. Those were my lectures for Japan, NHK TV Japan. You can see it in lecture 30 of 802. You can also see it in my lecture that I gave at the university in Delft. I gave that lecture on February 11, 2015. It is listed in my playlist, 1 hour lectures. However, the easiest for you may be to look at it in my farewell lecture. If you haven't seen it, you really want to see it. There's all the drama for which I have become famous over the years. Drama in my lectures. That smoke lecture is very, very dramatic. Trust me. Okay. So that was the solution to problem 123. If you couldn't do it, don't feel bad. We'll be friends anyhow, that is always a given. So, as I have said many times, the strongest conservation law in physics is that we will always be friends.